Hi, everyone. Thanks for joining us today. I'm Dr. Catherine Thial with the School of Public Health and the Transdisciplinary Stress and Environment Research Collaborative on Health Disparities, which we're trying to build out. We're really excited today to have Dr. Falk-Krzesinski with us. This is part of the D.W. Mitchell Lectureship Series and the Provost Faculty Seminar on Interdisciplinary Research. So we're excited to have her here today. Holly is the Vice President for Global Academic and Research Relations for Elsevier, where she's focused on strategic initiatives and stakeholder needs at research institutions and federal funding agencies. Her engagement activities emphasize collaboration related to scholarly communication, research and faculty information management, research analytics, expertise discovery and interdisciplinary research, and strategic planning for research enterprise. Prior to joining Elsevier, Holly had been faculty in the Arts and Science and Medicine division at Northwestern University, where she led initiatives related to research development, grantsmanship, and team science. She facilitated a multitude of trans-institutional collaborative grant programs spanning art history to bioenergy to translational medicine. Quite an array there, all with a research focus. Through her leadership with the annual International Science of Teams Conference Collaborative, Dr. Holly has been instrumental in developing a strong community of practice for team science and interdisciplinary research. She can tell you a little bit more about what she's done. We're really excited to have her here today, and she's a pioneer in team science, so we're lucky to have her on campus. Please join me in welcoming her. I should say, too, we have a reception in the gallery following her talk.
All right, thank you so much, Kat, for that nice introduction. So we'll do that. I have multiple microphones, and I got to remember to not move too far for that one. So thank you very much for coming today, and I'm really excited to be able to share around team science with you. I will warn you, though, I'm a microbiologist by training, so I'm just pretending to be a social scientist this evening. So a little bit about interdisciplinary research. I like this is from a colleague at the University of Chicago. I'm still based in Chicago, where we're still having winter, but it's nice to be here. But really, the opportunities that team research provides in terms of both scholarship and for the researchers as well, so for both the researchers and for the disciplines. So these are some of the things that I've been doing and have been involved in the time that I was at Northwestern University, where I was for 15 years, and then since I moved to Elsevier 18 months ago. But focusing on collaboration, networking, and teams, helping to connect researchers and the resources in pursuit of very large collaborative projects. In the case of art history, large collaborative project means something on the order of $15,000. Large collaborative in the life sciences means something on the order of $25 million. So the order of magnitude can be different, but it turns out people are the same. I have compiled, we just hit over 1,000 references in a team science resource library that's through Mendeley, and I'll show you a little bit more about that. I have published in this area, so I ceased doing microbiology research and over 10 years built up a new research program, and then developed and taught one of the very first ever team science courses, and I'll share some more information about that as well. And until I went to work for Elsevier, I was being a paid consultant to U.S. universities. Now I come on campus and you don't have to pay me, so it works out. Almost everything that I'm going to tell you about today is empirically grounded. That's really important to me, that we have evidence-based guidance for engaging in collaboration and interdisciplinary research. And you will be able to find all of these references on an open, free Mendeley library. It's the Science of Team Science group. So if you just do a Google search for Mendeley Science of Team Science, you'll get to it. You can join for free. If you haven't already signed up for your Mendeley account, you just need to do that first, but that's also free. This is the web-based version, and you'll see information. There's also a free desktop version of the software. This is especially those of you who are going to be doing more in this area. If you download the free desktop software, then you will see that you have pre-organized groups of references. Now, not the entire library has been grouped yet, but there's lots of good groupings and sub-files with lots of good literature, and we keep adding to that, but that's not visible on the web-based version yet, so you have to download. So just want to let you know where you can find all of the references that are included in the talk that you're going to see. It's also going to be available electronically, so Kat and Liz will make sure if you're interested, you can contact me directly, or you can get it from Kat. She has electronic versions already to share. I love this quote too, that society's problems don't fit neatly into the university's departmental grid. And Tulane's university's departmental grid doesn't fit nicely with Northwestern's, which doesn't fit nicely with Duke's, which doesn't fit nicely with the University of South Carolina, right? They're all just different. And how we've structured things for our organizational units doesn't really always match up with the science. Before I go any further, though, I want to just touch base on some vocabulary that I'm going to use so that we're all on the same page and you can understand the terms that I'm going to be using throughout. So we're talking about cross-disciplinary collaboration in teams. It's not that you can't have disciplinary collaboration. You do, and most of you are probably involved in that. But that's a much easier kind of collaboration. People are coming from the same kind of training and background, experiences, and culture. Everything I'm going to be talking about is cross-disciplinary collaboration. So team science, where you have people working from different disciplines. And there's 3 kinds of cross-disciplinary research orientations, where the idea is combining or integrating from more than one field. And we have multi, inter, and transdisciplinary. You can remember the order by MIT, that big old university. Multidisciplinary is really where you have more independence of the different disciplines working together, more sequential exchange of information and ideas. Interdisciplinary, thinking along a spectrum, a continuum, that you have more joint and interactive engagement between folks from different disciplines, partnerships. You might talk about complementarity of your research, a hybridization of ideas. And then ultimately, at the other end of the spectrum is transdisciplinary research, where the idea is to really have a more integrative experience, more interdependent and emergence of new ideas. And I have this represented through the fruit analogy. The disciplinary research is just this apple, and I'm hungry today, so I munch on the apple, and when I'm all done with the apple, I'm satisfied and I'm finished. Multidisciplinary research, more like this fruit basket, though. I'm a little extra hungry today, so I grab an apple and a banana. And normally we don't eat like two-fisted fruit eating, so I'm going to eat my apple, and when I'm all done, I'm going to start eating the banana. And for a little bit of time, I can taste the apple while I'm still eating the banana, but the time I'm done eating the banana, that's the only taste left in my mouth. And I know exactly when I stopped eating the apple and when I started eating the banana. Interdisciplinary research, more like the fruit salad, I can still discern all of the different individual fruits that have made up the salad, but when I take a bite, I get a little bit of the pineapple and the strawberry and the apple that are mixed in. But transdisciplinary research, my favorite of all, is when you put it all together in a blender and you make one of these delicious smoothies, which is perfect, especially soon when you hit 90s and high humidity here. It tastes better than all of the requisite pieces that went into it, but I can no longer discern the individual pieces of fruit. But I do know that they went into it. I do know that they have an important part of the flavors, and everything is better and more important than just the sum of their parts. So that's how you can kind of remember it in an order of MIT. So what kind of science then is facilitated by cross-disciplinary team science? Well, project, problem, and product-oriented research works very well in this domain, especially those problems that are urgent and complex, where there's a shared goal between the different investigators from different disciplines and with different expertise. Also, when they're working on a shared approach through a common facility. Northwestern University, where I'm from, originally has as its neighbor Argonne National Laboratory, which has one of the major accelerators there, and lots of research partnerships that go on because people meet up at the accelerator and they spend 4 days sleeping on site and connecting with one another. A lot of problems that are considered intractable or grand challenges, things where successive efforts might not necessarily pay off and where there's high risk but potential for high return. But importantly, I do want to point out that this is not mutually exclusive to individual investigator-driven research. And in fact, for basic knowledge development, we are going to continue to need individual investigator-driven research. But the fact is that our university structures are set up for individual investigators, and they're not set up so well for team and collaborative-based research as it was in pharma, which is where I came from. And so our organizational structures tend to pose a problem on a regular basis for us as we engage in interdisciplinary research and collaboration. And so that's the reason to focus on it. But as a scientist myself, I happen to be a big fan of data and evidence. And so there's a relatively new discipline called the science of team science. And this is really the opportunity to think from an empirical perspective, what can we do to facilitate scientific teams and their collaboration? It is a rapidly emerging field and really concerned with understanding what both hinders and what motivates people to work in teams and what makes them work very well. I think the field's grown in recent times because we have societal concerns for problems and a good understanding from society at large that science can help to address those. Things like sustainability and energy and emerging diseases. But we've also seen that there's a cost-effectiveness issue and an accountability by agencies whom we report to and where we get funding from. And a lot of these, especially in the life sciences or energy domain, where large collaborations are often valued at $25 million over 5 years, people want to know that they're going to get good return on their investment. We know some really cool things from the practice, and we can take the science of team science and put that into practice as well, not just using common sense approaches to things, which sometimes aren't as sensical as we'd like them to be. We do know that there's an increased demand for team science initiatives in both academia and from the federal funding agencies around the globe. And we have seen in the literature, there have been studies that in fact there are coordination costs for collaborative team-based research. And it actually does mean that it takes some more time to engage in this kind of research, at least proximally. What we get is a distal payoff in terms of acceleration over longer periods of time. So it really means that we have to understand what effective practices are and the best practices, and we have to train individuals, not just research leaders and students, but also institutional leaders and funding agencies to employ the best practices, right? It's not just enough that we go to school and we learn about them, but we actually have to translate them into practice. But that's okay. There's some really good practice, evidence-based practice that we can learn from already. I'm sorry for any of you who are graduate students in your early career or postdocs. It actually is increasingly difficult to make new scientific discoveries and discover new things. But nonetheless, you can get more out of it by working in teams, and we're seeing that in virtually all fields, including into the arts and humanities, and all of the sciences and the social sciences, that more work is being done collaboratively in teams. We also know from the literature that teams typically produce more highly cited research than do individual works, and that's important for us in academia. Teams that are more diverse and teams work that's done interinstitutionally, even more highly impactful by way of measuring citations. Virtual communities, when you have distributed collaborators, even more high impact research. And engaging in international collaboration, which you guys have lots of potential opportunity in that area, it shows a further boost in citation impact. But we also know from the same literature that dispersed teams fail often. So when they succeed big. When they fail often. But that gives us opportunity for intervention. That's the possibilities. The other thing that we know from the literature is that women scientists who do not collaborate are less productive than their male counterparts, and so it's really important. There's more studies underway now to understand why that is the case and to help develop appropriate professional development interventions. Here's some of the contextual factors that we know from the literature that impact team science, things that maybe you hadn't thought about before. Certainly there's the interpersonal, how people work together, but even issues of how we relate and our own individual attitudes, the interpersonal. There's things like the organizational, Kat and I were talking about things like promotion and tenure standards. The technology we have, right? How many of you have been in a webinar, right? And you're looking or you're doing a webcast and the refresh rate on the screen is so bad that you actually stop looking? Right? And so it's really hard because if I'm not paying attention or I'm distracted by what's on the screen, it's harder to engage with people. It also turns out that you need something like a 55-inch computer monitor. A full size, just to have somebody regular size, is inefficient and doesn't allow you to see the nonverbal cues that we would if we were just sitting next to each other. You have to have a 55-inch big screen TV to show somebody's hat on. Societal and political, so we have a lot of issues around the federal funding agencies and whether or not they'll fund big things. The physical environment and the spatial proximity. You know, I took the drive between uptown and downtown campuses, while it's not as many miles as it was between campuses at Northwestern, those real physical proximity differences pose problems. So these are just some of the areas and the places we think about. There's also the multiple level, and so we got together with some folks a couple of years ago and thinking about multi-level systems perspective, where team science is really a systems problem, not unlike the systems biology problems, but we're looking at systems from a sociology kind of perspective. And we have the micro, the individuals and cultures and backgrounds and experiences they bring to the table, the group level and the different group interactions, and how the composite group is made up, and then the macro level. So we have teams of teams. Most of you, if you are working in a team, you're probably not working in just one team. So there's multi-team systems in play and some really cool stuff. So we have to think about this also at multiple levels. And if we're thinking about policies and procedures and practices in an institution, we can't think only at this level or only at that level. We actually have to take all three into consideration. I'm particularly interested in the intrapersonal, that is our own individual biases and the things we bring to the table. What I've gathered most from my foray into the social science research domain is an understanding of self-awareness, and implicit bias that we all have. And it turns out it's not just implicit bias around things like our gender differences, but implicit biases we have depending on how we were raised up in science. So I'm a basic scientist by training in life and biomedical sciences, highly quantitative field of molecular biology. I read social science literature and I pick up papers sometimes and I'm like, where is the data? Right? These qualitative studies where n equals 3. I mean, where's the control group? I don't understand. It's very hard for me to wrap my brain around. But then there's also different experiences that we've had in our training. And so we looked at the literature back to the 1940s and collected everything that we could find reported on motivators and deterrents for collaboration. And I'm currently working with colleagues at George Washington University to put together an individual collaboration readiness survey. And as soon as I have it available, and if Tulane would like to be one of our pilot partners in thinking about administering this, we'd be really excited to have you guys engaged as well. And it's really kind of cool stuff, everything from the self-actualization, the psychological safety, but also in the kinds of collaboration and the levels of collaboration that you have. So we're also lining it up to two other frameworks for collaboration. So I'm really interested in this and really interested in what makes people tick, individuals tick, that wants them or allows them to participate. Plus, the way we're setting this up is that we can, in fact, do gender study differences, since we know that there are differences between genders and collaboration. Now, by now you might be asking me, so I kind of hear you, Holly, maybe I believe you even a little that team science is better than individual sciences in some case. Thankfully, the NIH ran some experiments for us out of their National Cancer Institute. They have big research centers on tobacco use. They're called their TTURCs. And then they had R01 grants, traditional individual investigator grants, that they funded over the same period of time in the same areas of research. And because they're the NIH and they have access to their own internal data, they could run these experiments. What I want to show you, in some really beautiful and very elegant data, is the TTURCs, or the research centers, are the blue line. And then they had two kinds of R01s. So one, the longitudinal R01s are comparative to match the 10-year duration and institutional infrastructure. And then what they called their stacked R01s were a comparison group designed to match the duration and funding periods of the TTURC. So no matter how you were doing comparison, they wanted to make sure. So these are the individual, red and green, individual investigators. These are the research centers. We do see that in terms of volume of annual publications, certainly some of the R01s started producing more papers faster early on, right? So this is evidence, again, of that coordination cost effect in the lag period. But after about 3 years, those research center folks, they really started, maybe right around the 4 year, they started cranking out papers. And then they just kept going.